So far in Chapter 4, we've talked about graphing a linear equation. What you might not realize is that we're ultimately going to talk about three different ways to graph a linear equation. So far, I've talked to you about method number 1, and that was making a table. So real quickly, method number 1, making a table. We are given an equation. Let's make something up. Y plus 3x is equal to 9. We're asked to rewrite this for y, plug in values for x, find the corresponding values for y, and then take these points and plot them on the graph. What's resulting, the line that results, is our graph. So that's one way to do that. Today we're going to talk about the second method. And the second method, we're going to be using intercepts. Eventually, we will talk about a third method over here. But I want you to understand I'm really not talking about a new skill. I'm talking about a new way to get from our equation to that same line. So our starting point's going to be the same, our ending point's going to be the same. It's going to be the stuff in the middle that's going to be different. So before we actually go all the way from an equation to a graph, let's talk about what an intercept is. This is the start of the paper that you probably have to be able to take your notes. The word intercept sounds an awful lot like the word intersect. Okay? And it's very close to the same meaning. So where two things intersect is where they meet. So if I take a look at my first graph, the graph crosses the x-axis, again this is my x-axis, right here, or at the point 2, 0. Therefore, the x-intercept, or where my line crosses the x-axis, is going to be at 2. The graph crosses the y-axis. Well, here's my y-axis, and my blue line hits my y-axis at this point. That's going to be the point 0, -1. Therefore, I would say that my y-intercept, or where my line crosses the y-axis, is at -1. If we take a look at our second graph, again, I have a blue line. I have my axes. Here's my y-axis and my x-axis. Where the graph hits the x-axis is right here, and that's at -4, 0. So I would say that my x-intercept is -4. Where it hits my y-axis is right here. That's the point 0, 2. So I would say my y-intercept is 2. Notice that your x-intercept is always going to be, okay, on this line. Therefore, I will have an x-coordinate, but my y-coordinate will always be 0. Likewise, my y-intercept, because it's always going to be on my y-axis, it will have a y-coordinate, but my x-coordinate will always be 0. Let's copy down some definitions. My x-intercept is going to be my x-coordinate of the point where, my line, or the line, I should probably write the line, but that's fine, intersects the x-axis. Again, you want to remind yourself that that's always going to be something, 0. Your y-intercept, just the opposite. So my y-coordinate of the point where, make that a T, where the line intersects my y-axis. and obviously the opposite of my x-intercept. I'm going to have 0, comma, something. Okay, so let's go through and actually find it. We're going to find the x-intercept and the y-intercept of this graph. Again, I don't have the graph, and I guess I could go through the practice of rewriting it for y and plotting all of my points, but that seems like an awful lot of work. So to find the x-intercept, if I know that my y-coordinate is always going to be 0, I can substitute 0 in for y and then solve for x. So I'm going to say 2x plus 7 times 0 equals 28. We know this term will just cancel out because it's equal to 0. I'm going to get 2x equals 28, and we should be fine at this point to get that our x-intercept is going to be 14. That means if I were going to graph this, I would be plotting the point 14, 0. My y-intercept, well, I'm going to substitute 0 in for x this time. So 2 times 0 plus 7y is equal to 28. We know this term will drop off. I'll divide by 7. And I'll get y is equal to 4. Therefore, I know that my y-intercept is going to be 0, comma, 4. If you flip your paper over, we have some practice. I'm going to ask you to do that in a little bit. But first, I want to go to the third example. The third example is going to actually take us from the equation to finding our intercepts to plotting the points to actually graphing it. So here's my original equation. I've written it 2 times because once I want to find my x-intercept and the other I'm going to use to find my y-intercept. So I'm going to plug in 0 over here for y. I'm going to x plus 2 times 0 equals 4. Once you do this a few times, you'll get used to the fact that that will drop off, and it will leave you with x is equal to 4. Over here, I'm going to do the opposite. I'm going to plug in 0 for x. I'm left with 2y equals 4, or y is equal to 2. So if my x-intercept is 4, I need to plot the point 4, 0. If my y-intercept is 2, I need to plot the point 0, 2. So I'm going to come down to my graph. 4, 0, right here. 0, 2. I'm going to draw in my line. You guys would just use a ruler. Draw in your line. Make sure that you have arrows on the end of your line. Because again, your line will continue forever. There's no restricted domain given in the problem. And there I have it. Okay, I went from an equation to finding my intercepts to graphing the line. What I want you to do is go back to this page. Take a few minutes, okay, and work on numbers 1 through 3. In the meantime, press pause on this video, okay, and when you unclick pause, I'll have all of my work for you. Okay, so here are your answers, guys. What I did on the left-hand side was I plugged in 0 for my y-coordinate. On the right-hand side, I plugged in 0 for my x-coordinate, and you can see my work that follows. What I'm saying here is that my x-intercept is 2. My y-intercept is 3. I'm going to scroll down so you can see my work for the bottom. Okay, if you have any other questions, let me know.